Second derivatives and stationary points, example 3. Find the exact coordinates of the stationary points on the graph of y equals e to the x over 2x minus 3. So we have a quotient here. U is e to the x, v is equal to 2x minus 3. So du dx is e to the x, dv dx is equal to 2. So dy dx is going to be v du dx, so that's e to the x 2x minus 3. Take away u dv dx, so that's 2e to the x, all over 2x minus 3 all squared. So that's going to be 2x e to the x minus 3e to the x minus 2e to the x all over 2x minus 3 all squared, which is e to the x into 2x minus 5 over 2x minus 3 squared. Now, dy dx is equal to 0 can only happen if the numerator is 0. E to the x can't be 0, so 2x minus 5 must be 0, giving us x is 5 over 2. So we have x is 5 over 2. If x is 5 over 2, then y is going to be e to the 5 over 2 divided by 5 take away 3, which is 2. So it's going to be a half e to the 5 over 2. Now, we need to differentiate again. Now, this is not easy. So u is going to be 2x e to the x, take away 5, and v is going to be 2x minus 3 squared. So du dx, well, this first part's actually a product. So v du dx, so that's 2e to the x, plus u dv dx, so that's plus 2x e to the x. Of course, sorry, that's 5e to the x there as well. So that's going to be minus 5e to the x. So that's going to be 2x e to the x minus 3e to the x. And then dv dx is going to need the chain rule. So that's going to be twice 2x minus 3 multiplied by 2. So that's 4 2x minus 3. So d2y dx squared will be v du dx, so that's going to be e to the x, 2x minus 3, multiplied by this v, which is 2x minus 3 squared, so altogether that's going to be cubed, minus u dv dx, so that's going to be 4 2x minus 3, e to the x, 2x minus 5, all over 2x minus 3 to the power 4. Now we can divide right through by a 2x minus 3 here. So that would give us e to the x into 2x minus 3 squared. Take away 4 e to the x, 2x minus 5, all over 2x minus 3 cubed. So I've just divided every single term by 2x minus 3. But what we need is d2y dx squared when x equals 5 over 2. And we don't actually need to work that out. We just need to know whether it's positive or negative. So it's going to be e to the 5 over 2. And that e to the x is a common factor, so we could take that out of the front. Now the 2x minus 3, so if we put 5 over 2 over here in here, that's going to be 5 take away 3, 2, so it's going to be 4. And then here, that's going to be 5 take away 5, it's going to be 0. That term was all going to come to 0. And then we're dividing that by 2 cubed, which is 8. So it's going to be 4e to the 5 over 2 over 8, and we could cancel this down, but the important thing is we can see it's positive, it's greater than 0. And that implies that the curve has a minimum at 5 over 2, a half e to the 5 over 2.